Hello everybody, Namaskar. In this lecture now, second part of cut fruits and vegetables, we will discuss the equipment for processing of cut produces, anti-browning treatment, technologies for shelf life extension of cut produces, and the packaging methods and storage of fresh cut produces. Okay. So, equipment, the operation process we studied in the earlier lecture. So, the various equipment, that is the pre-cooling. So, you can say that is the equipment, the immersion hydro coolers or shower type hydro cooler or vacuum pre-coolers. These are the equipment used for pre-cooling of the produce before it is sent for slicing or cutting operations, etc. Even details also how these system works. Earlier classes we had discussed, that is the principle of mechanical operations and principles of these equipment. So, in the immersion cooling, as you can see here, that is basically the fresh produce comes in the form of some suitable conveyor belts and it is immersed in a water which contains some, it is cooled water which contains some sanitizing agent or even that disinfecting agents, anti-browning agents, etc., which we discussed in the earlier class. Then for a particular time, depending upon the commodity, and it is taken out. Then the heat transfer takes place, that is the material get cooled and the water, it may become warm, then water goes to the heat exchanger and then it is further cooled down and it is recirculated. So, this is just in other slow shower type hydro cooler, that is here the cold water is just sprinkled on the commodity, and in the vacuum cooler, that is vacuum pre-cooler, that is inside that vacuum chamber, that is the, it is a commodity spray, okay, and it is pre-cooled by the, there are condensers, etc. These operations earlier it was told to you. Then peelers and cutters, you can see these machines are here, that is one lychee fruit peeling machine is shown, which has various components like rollers, gearbox, engine or collections of peels. So, it basically is provided with the conveyor, that is, and also the spiral which is containing spiral grooves. So, the material comes with this hoppers, comes inside the spiral groove, and basically by this rubbing action the peels are removed, peels are collected in the belt here, it is conveyed, and the peeled fruit is collected separately. This is a sort of very popular commercial vegetable dicing machine, where the different types of cutting devices are there internally. It may cut into a dice it into different shapes and sizes, cubes, dice, and so on. Okay. This is the process line for washing, dipping, and dewatering of fresh cut fruits and vegetable, maybe a single pass line. Here you can see that that is raw produce comes and it is a potable water which containing some appropriate amount of chlorine or acid, etc. So, it is sprinkled here, was the pre-wash, the commodity is washed, and after that it is sent for the cutting operation, cut vegetables, etc. That is, it is a with the conveyor belt, it is a inclined spray wash. So, the material is going there and then this second is sprayed, that is the water, acid, water, etc. It is sprayed here, and after that it comes vibra wash. Vibra wash, that is where that is it is a by abrasion or the material and the surface water, etc. by rubbing, etc. it is removed, then product chute and the spent wash water comes. So, this is the single line, and then there may be a flume system in which the raw product comes, conveyor belt, this is a cutter, and after cutting it comes a flume A, where this is, it is a potable water and chlorine and acid mixed with it, it is dipped. Then it comes and then flume B, then another flume it comes, it is same operation is done, and finally the surface water is removed and the product chute. So, these are the processing line for washing, dipping, and dewatering of fresh produces. Okay. Anti-browning treatment, in the earlier class we discussed in detail. It is a very important aspect. It may be physical treatment as well as chemical treatments can be used. Okay. that is the along with the washing, that is they should be dipped in various chemicals or by physical treatment by reducing the availability of the oxygen or temperature management, and it is recommended that fresh cut products should be kept at a temperature of about just above its freezing point, so that to avoid any form of enzymatic action or browning. Okay. So, different that is the reducing the oxygen availability, physical treatment, maybe immersing the product in water, brine, syrup to diminish diffusion of oxygen, dense phase carbon dioxide applied at low temperature in a solid liquid product consisting of fresh cut fruits in syrup as an alternative to the conventional thermal processing, or even edible coating or modified atmosphere packaging is used, and which eliminates the contact of the commodity with the oxygen and enzymatic activity is reduced. So, that these are the one way of reducing the oxygen availability. And then the chemical treatment like vitamin C dip, that is vitamin C is a very well known antioxidant. So, it reduces the oxidative process. Then acidulant, for example, 1% citric acid dip, it is used to adjust the pH of the product to a lower range, and which is not preferable for the browning enzymes to be active. Then by citric acid dip, the pH is brought lower and the enzyme is not able to act. Similarly, aromatic carboxylic acids like benzoic acids and their derivatives, cinnamic acid, sodium metabisulfite, etc., they are dipped into, so that the enzyme activity is inhibited. Sodium chloride, very common even in the case of potato chips, making potato slicing, that is the sodium which we commonly tell as brine solution, 1% or 2% brine solution. It is a weak inhibitor, thus elevated amount is required to minimize browning incidents in fresh cut products. Then these are the some of the fresh cut products, that is the anti-browning treatment for the fresh cut tropical fruits. Okay, that is chemical treatment in the raw mango slices, 2% weight by volume malic acid treatment is given, just it is a solution in the slices are dipped and it reduces visual browning. In the peeled guava cube, that is treatment method is aloe vera coating gel with additives, and in this coating gel the peeled guava cubes are dipped, that is dipping into the coating solution for about 5 minutes and then draining the solution and drying at around 30 degrees Celsius for 20 minutes. So, it results in less change in lightness and yellowness of the color. Similarly, in the fresh cut pineapple, the edible coating, that is the coating based on chitosan, pullulan, linseed, total nopal cactus and the aloe mucilages. Okay, and here layer by layer deposition of the coating material is done, and the obviously coated sample reduces the darkening of pineapple pieces. Okay. Similarly, in the fresh cut melons and papaya, the controlling atmosphere, okay, is a recommended method for application, and it reduces that, it maintains the color and extended the shelf life for 3-4. Combination method of physical as well as chemical combination, that is fresh cut rose apple, it is recommended, that is the temperature management, chemical treatment and edible coating. All these three is a delayed browning for about up to 72 hours. Fresh mango, that is, it is said that the pulse light and 2-minute dipping in that alginate coating solution and malic acid 2% weight by weight solution dipping. So, this combination treatment, it reduces browning and microbial count in the fresh mango slices. Okay. Technology for the shelf life extension, again that is the physical methods like modified atmosphere packaging, pressurized inert gas, then electron beam irradiation, pulse light, ultraviolet light, cold plasma irradiation, chemical technologies like acidic electrolyte water, nanotechnology, ozone treatment or biopreservation techniques like bacteriophage treatment with bacteriophages, bacteriocins or bioprotective microorganisms. These can be used for the shelf life extension of fresh cut produces. Okay. In fact, So many of these we had discussed earlier, so I will take up just that is principle of operation of these methods. So you see that some product, that examples we will show here. UV radiation, that is when it is treated mango slices, mango cut products treated with UV radiation, there is a reported in reduction in chilling injury symptoms and deterioration, and it improved the antioxidant capacity. Okay. Even melon cubes, UV radiation is reported to reduce 2 log microbial counts and compared to untreated samples. In case of peaches, there is UV radiation significantly reduced chilling injuries, increase the resistance of fruit deterioration. High pressure is reported to reduce the rate of respiration and ethylene production. Okay. In the cut apples, and accordingly the browning rate were delayed. Similarly, in the case of carrots, high pressure is reported to reduce 1.86 log cycle the aerobic bacteria and 1.25 log cycle yeast and molds. Okay. In pineapples, high pressure delayed the microbial growth and shelf life extension was there up to 6 days, shelf life extension was achieved. In avocado slices, high pressure is reported to result in the reduction of respiration rate and ethylene production. Okay. In pulse light treatment, in the case of fresh cut apple, it has been found effective in inhibiting the browning and microbial growth. In pulse light treatment found effective in inactivation of E. coli and Listeria innocua. In fresh cut watermelon, and it also resulted in decrease in the ethylene production. The cold plasma treatment in the cherry tomato, it has been found, although there has been no significant effect, there is no significant change in the weight loss, pH and firmness. So, the cold plasma treatment in the cherry tomato, it maintains its freshness, respiration rate and color also does not change after the treatment. Okay. In the case of blueberry, the firmness were reduced significantly after 90 and 120 seconds treatment, and all treatments synergistically are significantly reduced aerobic plate count from 0.8 to 1.6 log CFU per gram. Cold plasma in case of a fresh cut apple slightly reduced, that is up to 10% antioxidant activity and antioxidant content. Okay. So, here you see that is in this slide, it is shown the effect of physical treatment, that is the effect of ultraviolet radiation control and UVC radiation on the appearance, okay, and deteriorative index, that is A is its effect on 0 days and after 21 days. The control sample first and then UVC treated sample. You see that is how it is affecting the appearance, and the deterioration index also, that is it is the carambola slices, that is in the deterioration index is reduced even after 21 days also of the treatment. Okay. And in the UVC treated sample, where in the case of untreated sample, the deterioration index was high. And the other physical treatment like slightly acidic electrolyte water in the fresh cut lettuce, it is found significant in reduction of the total aerobic count. In the fresh cut cucumber, there is a high reduction in aerobic bacteria count, mold count, yeast count, etc., and it was found more effective than the sodium hypochlorite treatment. Even application of nanotechnology, nano emulsions coating, etc., has been found very effective in fresh cut kiwi fruits and pineapple, or even in fresh cut carrots, in controlling the microbial growth or in maintaining the color, firmness, etc. Okay. The another way of extending the shelf life is applying that is action with the bacteriophages, and there are several reports in the literature that, like for example, in the fresh cut honeydew melon and apple, the bacteriophage mixture SCP-LX1 and bacteriophage mixture LM103 and LMP102, they have been found effective against that pathogen like Salmonella and L. monocytogenes. In fresh cut lettuce and spinach, phage cocktail has been found effective against E. coli. In fresh cut lettuce, that EcoShield, that is lytic bacteriophage, has been found again effective against E. coli. Or in fresh cut melons, apples and pears, this Listex P100 bacteriophage, it is found effective against L. monocytogenes. So, even there were various, it is recommended several bacteriophages are available which can be applied, and these bacteriophages, these are basically the viruses which eat away the undesirable bacteria etc., and therefore help in increasing the shelf life of fruits and vegetables. Then fresh cut fruits and vegetables, that is, this is the process technology where take the harvesting, after that it is pre-processing and handling, cleaning, cutting, slicing, blanching, the freezing, detection of metals, packaging and storage. That is, storage is minus 18 degrees Celsius. That is freezing operations, that is it a low temperature, that is all the water present in the material, that is in the fresh cut produce is frozen, what is converted into ice, and then this is frozen and appropriately it should be packed, and after that it is stored at minus 18 or minus 23 degrees Celsius in the farm itself. So, this freezing technology, in fact, we in the next module we will take up and we discuss with the cold technology of freezing etc. So, that is an important aspect, okay, frozen material, and it keeps for the longer period of time. So, the different packaging material for these frozen products are recommended, that shrink film, cardboard packaging, IQF polythene, wax coated cardboards, flexible bags and so on. Okay. These are the equipment, possible processing equipment for frozen cut fruits and vegetables, that is in the continuous line, that is these are the minimum equipment we are suggesting. They are very standard, it is being easily available, like a product that is a feeding conveyor, then continuous online washing machine, then blanching system, that the appropriate blanching system, and after that the material can be directly conveyed to the blast freezer for IQF, individual quick freezing, or any other suitable freezing system can be used. That from this freezer it comes with the packaging, which is again done in the low temperature environment, and then the cool chamber, that is where the minus 18 degree or minus 23 degrees Celsius temperature is maintained and the commodity is preserved, stored in that. Okay. So, obviously, the packaging, very important aspect of the packaging method, packaging of fresh cut produces. As I told you in the earlier lecture also we discussed that you are removing the natural that is the natural protective covering to the fruits and vegetable, at the same time you are increasing the surface area, more area is getting exposed to the environment. So, here rate of deterioration will increase sharply, the rate of respiration, even contamination with the microorganism, contamination with oxidation reaction, very other biological reaction, physiological reaction. So, very important step is that is these cut produces should be properly packed, okay, in the properly, and packaging material they should have appropriate properties, particularly their barrier properties, barrier to oxygen, barrier to carbon dioxide, barrier to moisture vapor, barrier to light, and they should have proper strength, all these things, so that their properties, that is the color, flavor, texture and shelf life of the commodity can be properly maintained. So, modified atmosphere packaging, active packaging, intelligent packaging, edible coating. In earlier lectures we have discussed details about and even methodology and equipment for all these things. So, the same is applied here, but little more care, because here you are having more surface area, and the material is already cut, it is tender, it is soft. So, proper care has to be taken during this packaging. So, the modified atmosphere packaging, that is high oxygen modified atmosphere packaging or control atmosphere modified atmosphere packaging, intelligent modified atmosphere packaging may be done. Okay. So, and this basically we have discussed in detail earlier. The main thing in the crust is here is that around the produce we control the environment, so that O2 and CO2 so that its deteriorative reactions are stopped. So, modified atmosphere packaging, here in this slide I have given you that is what are the various produces. Like for sliced apple, the temperature may be 0 to 5 degrees Celsius and O2 less than 1% and CO2 normal, that is accordingly adjusted. This is recommended for the better proper shelf life and better quality. In the sliced kiwi fruit, 0 to 5 degrees Celsius temperature, okay, 2 to 4% O2 and 5 to 10% O2. So, in the most of these fruits community, you can see here whether it is shredded tomatoes, shredded cabbage, shredded sticks or carrots, etc. The 0 to 5 degrees Celsius temperature, that is more important, and in many cases 1 to 3%. In exceptional cases, some cases 5% O2, or in sliced oranges maybe 14 to 21% O2, and in other cases mostly that 10 to 15% CO2, in some cases sliced tomato 3% CO2, or in the sliced peaches 5 to 12% CO2. So, this appropriate, this oxygen, carbon dioxide level and temperature, this should be maintained. So, and that your packaging material should be appropriate enough and system equipment, so that you get this desired quantity. And here you can see effect of modified atmosphere packaging on the appearance of fresh cut melons. In this there is no modified atmosphere, and here the modified atmosphere, that is 14 days of storage at 6 to 8 degrees Celsius, and you see the appearance here. Even rate of deterioration, when there is no modified atmosphere, the rate of deterioration is high. In the case of modified atmosphere, rate of deterioration is much less even after 14 days of storage. So, that is found effective. Active packaging, again the same concept, that is it can be agents by antimicrobial, anti-browning and all those things. In details we have discussed these aspects earlier, so I will skip this. Similarly, intelligent packaging, there is also this aspect has been, but these are the why I am telling in this lecture, although we have discussed it earlier, but since this fresh produces etc., these are the appropriate packaging technologies which should be used to increase their shelf life. They like this indicator, they are very important. They can be, there can be temperature indicators, time temperature indicators, freshness indicator, leakage indicator, pH indicators etc., because the material inside is very active, very actively it will change, very fast it will change. So, these various indicators may be put on the packets, so that by these indicators will indicate where the produce is edible or not, it is safe to consume or not, it is good or it is spoiled. Okay. Because you cannot take a chance by eating this and testing this on yourself. So, this is becomes intelligent packaging becomes very important thing. Even data carrier, barcode or RF identifications etc., chemical sensors, biosensors etc., can be used. Okay. This is the some experimental result reported by some researchers, that is how the color change in the fresh cut vegetables is indicated by freshness indicators. You can see different color changes in the labels are there. So, they can, these are digital image and then RGB, LCC, and accordingly the indicators are available. So, that is one example. Similarly, various even TTI level indicators or freshness indicator is this, there is spoilage indicators or other color indicators, one can design any type of thing. Similarly, edible coating also is important, that is edible coating we have earlier studied, whether either it can be applied and then by using a dipping method or a spraying method or a brushing method, but the effect is in nutshell that a thin layer of the polymer is applied on the commodity, that is this is a either polysaccharide based coating, it may be protein based coating or composite coating and emulsion or plasticizer, but the coating material it should be appropriate to properly regulate the gaseous composition, and because it is very delicate. And another thing is that because it is edible coating, the coating material which you are using, it should not interfere, it should match with the color and flavor and texture of the eating quality, sensory quality of the produce. So these are some of the challenges in the case of edible coating applications. So effect of edible coating on fresh cut produces, it may affect the firmness and weight loss retention, it reduces the respiration rate, it preserves the polynutrients and discoloration retention or reduction of the discoloration, it reduces the malonaldehyde, electrolyte leakage and chilling injury, it controls the post harvest decay, antimicrobial and anti-browning effects are there, and it increases the shelf life. So edible coating has been found effective in all these aspects. Okay. Here you can see that how that it is a fresh cut ready to consume that fruit, that is, and then after that cucumber, it's uncut fruit started degradation following the storage. Okay. Whereas the coating of the fruit is applied and then it is kept even for the after storage also. You can see that fresh cut after storage how it is, and the coated material how it is, it improves the appearance. So the bioactives, even the nano based emulsions like carbazole, lemongrass oil, marandrine essential oils, alpha tocopherol, etc. can be used for the application of the coating. But in the coating, that is again the type of the coating material, thickness of the materials and the gas exchange permeability, permeable properties, etc. These are the some of the challenges which needs to be resolved. Okay. So here you can see that effect of coating on the appearance of fresh cut cantaloupe with and without the edible coating, that is after 0, 9 and 18 days of storage at 4 degrees Celsius. Okay. That is the 0 days, these are that the first top 3 is the control sample, then the bottom 3 is the chitosan coating, then other is the this linseed mucilage coating, and the combination bottom one is the LMCH combination of linseed mucilage and the chitosan coating, and it has been found effective in reducing the juice leakage and softening of the product, and it preserves the characteristics of the color and odor, and it is even visible. You can see it has been found very effective, that combination treatment is the color is almost similar to that of the natural fresh one. Then antimicrobial packaging, again it very important, that is the antimicrobial modified atmosphere system or antimicrobial edible coating, that is in the edible coating material which is being used, in that antimicrobial or antioxidants can be added, even natural antimicrobial films, that is the synthetic antimicrobial films may be used, where the natural antimicrobials even can be used. The various natural antimicrobials are there, that is either from the animal products or from the fruits origin, etc. They can be infused either in the packaging material or the edible coating material, so that it reduces that. So the antimicrobial and antioxidant packaging system is very important for fresh cut produces. Okay. So it reduces the total microbial and chloroform count, minimizes the loss of chlorophyll, and enhance the storage life of the produce. Okay. So after the packaging, obviously the storage of the fresh cut produces is very important, and in whole crux of the problem is that is storage, in the packaging and all this, that is as far as possible less than 4 degrees Celsius, refrigerated storage, cool temperature, maintaining low temperature during transport and storage of fresh cut produce is a very critical aspect. because by this you will able to control enzymatic browning, you will be able to control shriveling, okay, or most of the sensory disorders in the fresh cut produce, etc. They are slowed down by low temperature storage. Okay. Storage of produce at adequate refrigeration temperature even are reported to limit pathogenic microbial growth also, that is particularly those which are of course psychotropic, for example L monocytogenes, etc. They can also be their growth will be suppressed if it is temperature is less than 4 degrees Celsius, etc. Okay. In fact, L monocytogenes populations in some experiment remained constant or decreased on packaged vegetable when it is stored at less than 4 degrees Celsius. Okay. Mesophilic pathogens like Salmonella and E. coli are unable to grow where the temperature control is adequate, that is less than 4 degrees Celsius. Okay. Ensuring the temperatures are kept at or below 4 degrees Celsius throughout the cold chain is essential for microbial safety, and it requires considerable attention to detail. A larger percentage of fresh cut produce are stored and marketed in modified atmosphere packaging in conjunction with chilled storage and other prevention protocols. Time temperature indicators embedded in the packaging may have a significant role in ensuring the safe storage temperature are used. Okay. So, with this I now will summarize this lecture, that considering the increasing demand of consumers and food industry as well as environmental preservation, the use of additive based natural compound could be an alternative to chemical synthesized compound in the preservation of fresh cut fruits and vegetables. Edible coating, modified atmosphere packaging or such other system are effective and they should be followed. And even the soft hurdle technology concept which we considered earlier, so these should be applied, a combination of coating, a combination of thermal treatment, mild heat treatment, blanching, reduction in the adjustment of the pH, etc., and proper packaging and storage at a low temperature. This will help in maintaining the quality of the fresh cut fruits and vegetables as well as its marketability and safety. So, these are the references this lecture. Thank you very much for your patience hearing.